Hello everyone, myself Kamna Singh, Assistant Professor in Computer Science and Engineering Department in Akgec Engineering College. Today we are going to discuss the addressing mode in computer organization architecture lecture, and this particular subject is continuing in the second year in the IT and CS branch both. So it is very important topic, and when the semester is coming and the semester exams, this particular question will always become in your semester and sessional exam. We are going to discuss this particular addressing mode definition also with the numerical portion. So let's start with the addressing mode. The first thing is, what is the addressing mode is there. The addressing mode is specifying the rules. Actually, what is the addressing mode? Actually, all the operands you can understand what are the operands. Suppose that there is a C equal to A plus B is there. So plus is the opcode on which the particular operation, whatever the operation you are going to perform, that is the opcode, and on which variable you are going to perform the operation, that is called the operands. Actually, in the addressing mode, we are going to discuss actually where operands are residing. Where the operands are residing, either it is in the memory or a register. So we are getting the address of that particular operand actually for finding this addressing mode. So addressing, and the next thing is, actually the addressing mode is refers to way in which the operand of an instruction is specified, and the addressing mode specify a rule for interpreting or modifying the address field of the instruction before the operand is actually referenced. So you by this definition you can understand that the particular operand is what? Operand where the operations are on which variable you are going to perform the operation, that is the operand. And opcode is what? Whatever the operation. If I am saying that there is a file 1.txt, it means what? That particular file 1.txt, and I am going to open that particular file. So what is the operand and what is the opcode here? That is, opcode is what? On which particular operation you are going to perform. So here we are going to open that particular file. So opcode is here as an open, and the file 1.txt on which particular you are going to perform the operation. So file 1.txt is here as an operand. Fine. So now you can understand the what is operand, and in the addressing mode we are going to get the effective address. And what is the meaning of effective address? This effective address is actually nothing but it is the actual address of the operand where it is going to reside. Either it is in the register or in the memory. So in the effective address, for the calculation of the effective address is also called as an offset also. So offset is determined by adding the combinations of the three address, that is displacement, base or index register. Base register is called as a BX or a BP also, and the index having a psi or DI. Now let's discuss about the addressing moding technique. There are 10 addressing modes, so you can find out the addresses. First of all, we have to understand this is the computer instruction format. Computer instruction format means whatever operations you are going to execute. Suppose that you are browsing that particular file, or you are opening the file, you are actually operate the instructions or a computer instructions. So the computer instruction format is always, that is opcode, mode and address is there. Opcode, mode and address. So the first thing, opcode, mode and address, actually this is for the computer instruction format. In the computer instruction format, there are, you can see here, there is a instructions type 1 address, 2 address and 3 address instruction. Whenever any particular numerical question will be coming, so the lines will be considered a 2-word instruction or a 1-word instruction. So you have to know that what are the types of instructions and how you are going to represent it that. Fine. So if the 1 address instructions are there, and in this particular box is represented as in memory, and 1 address instruction means computer instruction format is what? Opcode, mode and address. So you can see here in the 1 address instruction, simply you can write it here, that is opcode, mode and instruction. and whatever the address, suppose that it is residing in the 200 address. So you can simply write it here, that is a 200. At the memory location 200, there is a one address instruction is residing where opcode, mode and instruction address is there. So this instruction address, you can say there is a address is actually fine. Now in the two address instruction, as you know, there are three parts. What? Opcode, mode and instruction is there. But now we have only two parts. That is, I have opcode, mode and instruction address. I have only three parts are there. Opcode, mode and address is there. And now there is a two address instruction. Two address instruction means what? Now I have three fields, but I have to represent this into the two addresses. Suppose that the address location is 200 and 201. That is fine. But how these three is to be accommodated in the two parts? This address part of the instruction is treated as a single part, and this two instructions, these opcode and mode, will be treated as a single, as an individual. So you can write it here as an opcode and mode. And here in the second part, there is a address part of the instruction. So while you are going to write the two address instruction, always you have to write like this: opcode, mode and address. Don't write it here, that is the first part is the opcode and the second part mode and address. This is wrong. Actually, we are treated it here as an opcode and mode, that is as a single unit, and the next is the address part. So remember that we are writing here as an opcode, mode and address in the two address instruction. In the three address instruction, that is simple, because we have a three address field and there is a three memory locations are there. So that is simple. You can write it here like opcode, mode and address. Opcode, mode and address is there, and the locations will be 200, 201 and 202. Simple. That is because we have a three address fields are there and there are three particular memory locations are there. So directly you can, it is just like that I have a three students and there are a three chairs to sit. So that's why there are three chairs and the three students will be sitting there. But if I have a one bench and I have a three student, then I have to be seated as in a one bench, these three, for a one address instruction. In the two address instruction, one bench is there, but the three students are there. So we have two benches should be there. There are two benches and three students. So in a one bench, two students to be seated, and in the second bench, there is a one student will be seated. By this example, you can remember that how you are representing the one address, two address and three address instruction. Now, there are actually 10 types of addressing modes are there. There are implied mode, immediate mode, auto increment, auto decrement and direct addressing mode. There are so many addressing modes. So, one by one, let's discuss about what are the implied mode. The implied mode is what? It is nothing but when your address part, you can see here, that is in the opcode, mode and address part. There are three instruction fields are there, computer instruction field, that is the opcode, mode and instruction. In the implied mode, it is also called as an implicit mode or implicitly defined mode. That is what? That is when the operand is implicitly defined in the instructions, then it is called as an implied mode. Suppose that I have a particular example as ASHR accumulator. Fine. Suppose this is the example, arithmetic shift right accumulator. At that moment, accumulator is free and whatever the content part of the accumulator, you have to arithmetic shift right. So it is implicitly defined, means I don't need any extra data or any extra register to accommodate this particular value, final result to get. Suppose that AC having 1100. So you can simply write ASHR accumulator and you can get simply 111 and 0. So at that moment you cannot getting any extra information or any extra register needed to find out this ASHR AC. So it is implicitly defined in the instruction, that is called implied mode. Whenever it is in the question coming, that is what is the implied mode. So at that moment we have to calculate the effective address. This particular effective address is only you have to write it is not applicable or applicable. Applicable or not applicable, only you have to write. There is no integer number or an address part of the instruction should be written over here in the effective address. And you have to remember that what is effective address? Effective address is the actual address of the operand where it is residing. Means may be possible this operand can be stored in the register or a memory also. So effective address. In the implied mode, addressing mode, it can be written over here, that is simply that is a not applicable or a applicable. Fine. So in this situation we have to write in the effective address applicable. If there is a accumulator or you can see load to AC, the second example, if I am taking like this, so I don't know that which particular instruction or which particular content I have to load. I don't know. That is, it means this particular instruction is not giving any information about what is going to be loaded in the AC. So that's why this is not applicable mode in the implied. Now in the implied mode, simply you have to write it as like load to AC. If I am written over here, that is a load to AC, means what? There is whatever the instruction, even though if you can see here, that is a AC having a 1100. So that is okay, 1100 is there, but I don't know what I am going to load in the AC. So that's why in the implied mode, if I am taking this example as in, if I am taking this example, so this in the implied mode we have to write as in getting the effective address as not applicable. Only you have to write this in a not applicable. If I am writing here in the implied mode SHR accumulator, means what? We have to, whatever content present in the accumulator, you are shifting right of that particular content. It means you know that whatever you have to do. It means in the implied mode, that particular content of the instruction is shifting right. Means in the implied mode, if I am taking here as a implied mode, so this particular effective address, you have to write it here as an effective address will be written over here, what? That is applicable. Not write your answer. You have to not to write that what is the SHR AC, what is the answer, what is the response. No, you have to write only effective address in the implied mode is applicable in this situation. Now next is the immediate mode. In the immediate mode, actually what? Immediate mode, we specify the operand of the instruction itself. Means whatever instruction address is given in the computer instruction format, that is actually the operand. That is actually the operand. It means what? Instead of specifying the address of the operand, the instruction address becomes the address of the operand. Suppose that you have taken the example as an opcode mode and address. Opcode mode and address. And address is 600. Suppose address is 600. So in the immediate mode, the effective address will be whatever the address of the instruction is, that will be the effective address, that is 600. Simply, that will be the instruction address or a operand address, that is a immediate mode. Now the next one is the direct addressing mode. Suppose that you are the student and you are sitting in your classroom. The teacher wants to search you. At that moment, the teacher is going there in the classroom, where the classroom is there, whatever the location, and you that particular teacher will be find you. So at that moment, actually what happened, I am in the direct addressing mode. What we are going to do? in the effective address, I have to calculate the effective address. Fine. In effective address, if I am going to calculate, it means the operand address. Operand is where the operand is actually residing. So, in the direct addressing mode, suppose that I have opcode, mode and address is there. And address is, suppose there is a 500. Suppose this is the address. In the direct addressing mode, this is the memory, and in the memory, at the address of 500, operand is residing. This operand is residing in the 500, means in the direct addressing mode, whatever the address part of the instruction, that is the 500. So, this is the operand address will be there. And the next is, so what you have to written, there is a effective address, and the effective address is what? That is what? That is the 500 will be there. This is the effective address. Now, in the indirect addressing mode, suppose that in this effective address 500 is there and the operand is there. This operand number is suppose 314. So, this operand address is, suppose that 314 is there in the indirect addressing mode. Indirect addressing mode is nothing but it is the address field of an available instructions, gives that the effective address gets stored in the memory. So, you can calculate by this. In the indirect addressing mode, how you are going to calculate? Suppose there is a address part of the instruction, the same value, that is a 500. In the direct addressing mode, you are getting here as an operand, and operand is 314, and this is the memory location of 500. This 500 you can call as a physical address, and this is the memory. So, in the memory, there is this is the direct addressing mode. Now, where the operand is residing in the indirect addressing mode. This is the indirect addressing mode. In the indirect addressing mode, this particular 314, suppose that there is a address is 314 is here. Fine. 314 is here. So, this is the indirect addressing mode. This particular value here is actually the operand. So, the effective address you are going to calculate is where the operand is residing, that is 314, and whatever the operand value is there. So, you can see here, that is if I am taking a particular example, which I am searching that particular student in the classroom. If that particular student is there, so it means direct addressing mode. I am getting that information. Again, that particular student is not in the classroom, he is in the canteen or somewhere else. At that moment, what I am going to do, because I don't know that particular student where it is. So, I am going to the classroom and finding out that particular way that according to their students, that particular student is in a mess or a canteen or whatever the another building. Fine. So, I am getting that particular information from the classroom only. Fine. So, this is the same procedure in the direct and indirect addressing mode. In the direct addressing mode, how you are getting that particular address part of the instruction giving the operand. And the solution is that I have to find out the address of the operand where it is residing. Either it is in the memory or a register. So, here I am getting. In the indirect addressing mode, I am not getting that actual operation or actual operand where it is. But in the indirect addressing mode, I can get the indirectly the operand is residing here in the particular location. Right? So, that is the indirect addressing mode. Now, in the register mode, the operand exists in those registers that reside within the CPU, not in the memory. In the register mode, that particular instruction will be stored in the register mode. Right? But in the register mode, effective address is not applicable. Here, effective address is not applicable. Simple. And indirect addressing mode, suppose that particular instruction address is stored in the register as a 100. Fine. So effective address will be means operand is residing actually at the 100 place. That will be the effective address. So you can see here that is a register indirect addressing mode, the instructions available us to define the particular register to the CPU. Fine. The references to the register is equivalent to the specifying any memory address. There is a auto increment and auto decrement mode is also there. We can discuss it here with the questions, or you can see here auto decrement and auto increment. Auto increment mode is same. Auto increment mode is same as in register indirect addressing mode. Auto increment, but the effective address will be incremented by the one after the execution of the instruction. So this is the auto increment. In the auto decrement, whatever the register size, the effective address will be lesser number of 1. Means you are decrementing the register. That is the auto decrement. Index addressing mode. Here you can calculate the effective address as content part of the instruction plus index register value. Whatever the index register value is given is to be added with the content part of the instruction, so you can get the effective address. And the relative addressing mode, in the relative addressing mode, there is a particular whatever the PC, you know that na PC is the program counter. What will be the going to be executed? PC will hold the address of that particular instruction. Whatever instruction is going to be next executed, PC will hold the instruction. So in the relative addressing mode, or you can say the base register mode, you have to calculate that. How you are going to calculate? The effective address equal to the PC plus content part of the instruction. So this is the relative addressing mode. Let's discuss about the question. Generally, these particular questions will become, that is a consider a 2-word instructions, load to AC, and the location is 200 and 201. So the first line you can get here, that is there is a 2-word instruction. That's where there are the 2 memory locations is given. If there was a 3-word instruction, so there will be a 3 memory locations will be there. If there is a 1-word instruction, so only 1 memory locations will be there. And the instruction is what? That is a load to AC, and that instruction address is in the 500. Content of the PC has a value 200, and the content of the processor register is 400, and the content of XR is 100. This is the question. How you are going to start? First of all, you have to make the designing of the memory. Even though there is not written in the question that you have to design a memory, but every time whenever you are going to solve the addressing mode question, you have to design the memory. Fine. So first of all, there is a 2-word instructions. So according to that 2-word instruction, opcode, mode and instruction. The first word is opcode, next is the mode and instruction address. That instruction address is actually 500. Fine. Address instruction is 500. So you can get here opcode, mode and instruction. This instruction is what? Load to AC. This is the load to AC. So you can see here that is the location is 200 and 201. Simple. You have to find out the implied mode. The first one, that is a implied mode. In the implied mode, you can see here there is a instruction is what? That is a load to AC. Means in the implied mode, effective address is not applicable, as we discussed earlier. In the second mode, that is a immediate mode. In the immediate mode, the particular instruction is going to become the effective address. So finally you can get here, that is a effective address, and what is the operand? So operand is what? Actually you have to create a register, and the register name is AC. And why I am writing here as an AC? Because the instruction is AC. If that particular instruction is going low to R1, so always I am writing here as a register as R1. Here low to AC, that's why I am writing here as a register, that is a AC. Fine. So in the immediate mode, whatever instruction address is given, that will be the operand. So in the AC, there is a 500 will be located, and the effective address is what? This 500 is actually residing in the 201. So effective address will be 201. Fine. In the direct addressing mode. Direct addressing mode, in which direct addressing mode you have to calculate? There is a opcode mode and instruction, 3 instruction, and this is the operand. This operand is residing here, and there is a 500. Now the tricky part is come. Here I don't know the operand value, but I know the address of that particular value. So this operand value I have to assume. But for the assuming, there are 3 restrictions. First, that particular number should not be repeated whatever your question is written. And the second, if it is a 3-digit number of the memory location address, so this particular number should be a 3 address. Suppose that 3 values should be there, and it should not be repeated. Fine. So I can calculate it here. That is a 500. Suppose that, let's assume there is a 500, and I am writing it here as an 316. Suppose this number I am assuming. You can also assume, there is no restriction on that. Only restriction is that this number should not be repeated with whatever questions written over there. And the 500 direct addressing mode. In the direct addressing mode, it means the effective address is there, that is a 500. But what will be the operand? Operand is AC, and you are assuming this as a 316. That's why it is a value. In the direct addressing mode. In the indirect addressing mode, you can calculate it here. Opcode load to AC is there. Now you can calculate the indirect addressing mode. In the, let's assume there is a 316 is there. 316, and there is a some value you can see here as is a 614. Suppose. So in the particular, that was a 3 and the 4th. That is a indirect addressing mode. Indirect addressing mode, what will be the effective address? Effective address will be this 316, and in the operand there is a 614. These 2 numbers we are assuming. And how we are going to assume? Because there is a address, opcode mode and instruction, and the address was there. There is a address of the instruction is there. This is the opcode mode and instruction, and this particular opcode, this address was 500. This 500 was, suppose, is in, this is the direct addressing mode. And indirect addressing mode means what? This 316 hold the operand address, this 316, and here is the operand actually residing, and this operand address we are assuming. So you can calculate indirect addressing mode. Now the next part is, after that indirect addressing mode, there is a register addressing mode. In the register addressing mode, you can calculate with the whatever the register value given in the question. R1 is a processor register, and there is a value is 400. Fine. So in the register addressing mode, this register addressing mode, you can get the value as XR register value is 400. But in the register addressing mode, effective address is not applicable. So you are just leaving it here, and the operand in the accumulator store is as an 400 in the register addressing mode. Next, register indirect addressing mode. In the register indirect addressing mode, whatever value is there, means suppose there is a register address part and there is a register value is a 400 and the some operand is there and this value goes here and here actually the operand. This is the register indirect addressing mode, just like the indirect addressing mode is there. So, register indirect addressing mode you can get as an operand addressing mode is there. So, in the register indirect addressing mode you can calculate it here, that is a 400. Suppose that 400 is here and this particular 400 having a value as 716, suppose. So, this particular number I am assuming, but this 400 is given in your question. So, 716 I am assuming, and you can also assume any number which is of 3-digit number and which should not be repeated in your question. So, in the register indirect addressing mode, effective address is what? Effective address is 400 actually. That is whatever the register value is there, which is given in your question. And the operand, in the operand, what will be the operand value? That is a 716. And the next is auto increment mode. Auto increment mode is same as a register indirect addressing mode. Means same register indirect addressing mode. Effective address is 400 and the accumulator value is 716. Only you have to write the note that after the execution of the address of the instruction, the particular effective address will be incremented by 1, or you can say effective address will be incremented by 1 after the execution of the instruction. Now, the next is auto decrement mode. In the auto decrement mode is what? Now, auto decrement mode. Auto decrement mode is simple. That is a whatever the register value is given. XR register value is given as 400. So, in the auto decrement mode value is writing over here as XR equal to 400 and XR value is what? You are going to decremented. Effective address is 400 minus 1, that is 399. So, you can write it here as effective address is 399 and suppose that this is the 399 address of the memory location and you are writing it here as an 834. So, the operand value will be, this is the accumulator, operand value is 834. So, the operand value will be 834. This 834 I am assuming, you can also assume, but this 400 you cannot change. 400 is already given in your question. So, this is the auto decrement. Next is your index mode. Index register addressing mode. In the index register addressing mode, what will happen here? That is a effective address you are going to calculate with content part of instruction plus index register value. Content part of the instruction plus index register. So, you can see here in the question, in the index register value is 100, fine. So, the index register and the content part of the instruction is 500. As you can see here, content part of the instruction is 500. So, in the index register mode, 500 plus IR is 100. Effective address is 600. At the time of 600, suppose there is a 961 is there. So, the operand value in the accumulator, this 961 will be as an treated as an operand in the index register addressing mode. Next is This 961 is again I am assuming, because I know the index value, I know the content part of the instruction, but I don't know the operand value. So you can assume that. But every time you have to calculate the effective address of each addressing mode, that actually where the particular operand is residing. Fine. So last mode is base register mode, or you can say this is also called as a relative addressing mode. Relative addressing mode or a base register mode. Here you are going to calculate effective address with the plus PC value. PC is the value where you are going to instructions to be next executed. So content part of the instruction, as you know, that is a 500. But what is the value of the PC? In the PC value, currently this instruction is going to be executed. So the next instruction will be this one, and the memory location will be 202. Fine, because the 201 is currently executed. So the next instruction is going to be executed is 202. So in the relative addressing mode, content of PC, you can write it here as a content of PC. This content of PC is 202, or you can write it here 500 plus 202, that is what? 702. So the effective address is 702, and the operand value is calculated here. Suppose this is the 702 and there is a 623. This is the address part of the instruction. So these are the 10 addressing mode you have to calculate. Generally in your paper, these type of questions will become. So this is the particular addressing mode example, whatever we are discussing over here. You can see here, that is a load to AC and the mode was there, and the 201 and 202, that is our next instruction. And in this particular situation, program counter value is given, program register, and this is the question. We can verify this. Fine. Thank you.